Hello. In my last video, I talked about general research approaches like qualitative and quantitative and theoretical. In this video, I want to get more into specific types of qualitative and quantitative research and important concepts for these two approaches, and some important things you need to know if you are reading papers as sources for college papers that you are writing in college or maybe early in graduate school. So, sound fun? Of course it is. Let's get started. Okay, basic concepts for qualitative and quantitative research. Now, my main background personally is in quantitative research, and that's what I prefer. I have done a little bit of qualitative or mixed methods research, so I have a little bit of experience, so I can talk about that too. So qualitative, let's start with qualitative. You start with unstructured data. There's no inherent structure to it, like entire texts, conversations, or some other kind of data that has no inherent structure to it, and you have to find structure or impose some kind of structure to make it semi-structured or partly structured. And that's the opposite of quantitative, which to begin with is highly structured data. So qualitative data, what kind of data do you use? What kind of data do you get? Well, it might be open-ended survey questions or interview questions. You might give a survey and have people write up responses free form. That is, they can respond however they like in a sentence or multiple sentences or a paragraph. So it's unstructured data in that sense. Or you could ask them interview questions and record the interviews and then transcribe the interviews. Either way, the responses are open-ended. They respond however they like. And it could be short responses or longer responses. Hopefully longer responses, because you'll learn more from that. Then you have ethnographic research. And so imagine an anthropologist observing a people group or tribe. Typically, what do? At least traditional anthropology research. Well, they spend time there. They do a lot of observing, and they write very detailed notes about the various things that they see. They describe particular scenes in a lot of detail and make a lot of detailed notes and then inferences. And that's the beginning of ethnographic research. Now, in addition, they will also do interviews with the local subjects, but the basic observational research and recording, taking notes, that's your traditional ethnographic research. Now, today it might involve also making video recordings and other such things. This traditional research method from anthropology has been kind of imported into some other research areas. In education research, there is a whole field of qualitative education research involving observational studies, where a researcher simply sits and observes in a classroom, at the back of a classroom, and takes notes or maybe records with a video camera. And later they're going to analyze what has happened. And so it's observational research, often with note-taking. This has also been applied in a certain area of linguistics called conversation analysis, where language researchers will record conversations, audio or video recordings, and then they make extremely detailed transcriptions of everything that was said, including down to the second by second transcriptions of pauses and intonations and breathing and other things that are kind of important to like understanding the meaning and communication. So this is ethnographic research. And when you have data from, say, open-ended questions, observational studies, ethnographic research, or there are other kinds, of course, a case study. A case study is where you write a very detailed sort of story about a person. It could be a language learner and their experiences based on your interviews and surveys. It could be a company and the history of the company, and particularly their performance, success or failures. So anyway, you have this data. How to analyze it? Well, you want to impose some sort of structure and make it semi-structured, that is partly structured, not fully structured in a way that you'd put it into like a spreadsheet to analyze data, but some kind of structure that you would allow you to see patterns, allow patterns to emerge. Now, sometimes a researcher might just look at the data and look for patterns or categories that emerge from the data. You can then start to classify things on your own, or you might do this based on some kind of a theory, model, or framework in the field that you use in order to then classify or categorize things that you observe in your data. And that's one common thing that's done that allow you to see trends, patterns, interesting things to see. You compare what happens in different kinds of situations and kind of draw inferences from that. You analyze and kind of get an understanding of what kinds of things are going on beyond what's just visible. Another way of creating semi-structured data is coding. That is, you go through and assign specific codes or categories to data. Let's say you do an observational study of classroom interactions and you want to categorize the social patterns, and so you code. This is like teacher and student talking, or this is student and student talking, and this is teacher lecturing, or maybe activity types. This is a teacher-led, teacher-based activity, or this is a student-centered activity, or something like that. You have some system of kind of putting codes into things, simple kind of like letter codes or something like that. And that would allow you then to create some like counts or averages or frequencies or percentages. And that gets into the next type of qualitative data, which is descriptive statistics. Statistics that simply describe. Doesn't tell you why, doesn't tell you if there's any relationship that's true or meaningful, it's just descriptive. Things like counts, sums, averages, percentages, ratios, frequencies, how often something happens, descriptive statistics. And it's from looking out at these kinds of data that you see hopefully patterns or trends, find some comparisons and contrasts between different categories in your data. One thing that's occasionally done is triangulation, and that's when you collect two different types of data in this, or three or more in the same project, in the same study. It might be, for example, a combination of observational data and open-ended survey data, and then maybe coding and calculating some percentages based on codes. So you've got two or three different data streams or data sources that allow you to maybe do a more comprehensive study and make sure that the results are kind of consistent. The results of your observational analysis and your coding and your survey analysis are consistent with each other. So it's kind of triangulation. Or maybe you do some coding and run a simple statistical analysis and use that as a mixed method study, a qualitative study with a little bit of quantitative analysis. Those are things that people do in qualitative analysis. Triangulation is one thing that ensures that the results may be more reliable, and not many people do it because it's more complicated and more involved, but a study involving triangulation, or at least two or more different types of qualitative data or mixed methods data, are maybe more reliable. And again, the caution with qualitative data or qualitative research is it's exploratory, and it can be very useful for exploratory purposes. If you're trying to explore something that's kind of really complicated and hard to it's kind of hard to break down and analyze. It can be good for that, especially for an initial understanding, or for understanding things more holistically, the big picture kind of perspective of what's going on, and maybe that's what you want. However, qualitative research doesn't really allow you to prove anything, and that's a shortcoming, and maybe for many qualitative researchers that's not a concern, but that is a limitation of qualitative research. It doesn't allow you to prove anything for sure. It doesn't allow you to prove hypotheses. It can allow you to form hypotheses that you can later prove quantitatively, but it's in itself for more exploratory purposes or holistic understanding. Now let's move on to quantitative research, my favorite stuff. So there are many kinds of quantitative data that you can collect, many kinds. Just a few examples. You can give surveys with objective or close-ended questions. There's things like true, false, yes, no, or rate something on a scale of 1 to 5 or 1 to 7 that gives you some numerical data. That kind of survey data would be quantitative. You can do laboratory experiments. You can do classroom experiments. I did some laboratory experiments based on psychology research for my PhD. Very detailed, but kind of fun. You can do classroom experiments. It's kind of hard to do, but a lot of people do it in language education, where you have at least 2 different classrooms, and one classroom is taught one way, a certain skill, and another classroom is taught in a different way, and you compare the results. And when you compare results, you're going to use not descriptive statistics, not the, at least that's not the main thing you're relying on. You use what's called inferential statistics, which are used to infer whether 2 things are really related, where there is a significant, meaningful relationship between 2 things, or if, there is something real going on, if this factor is actually having a meaningful effect on what you're measuring, a real relationship, or maybe even a causal relationship, X is causing Y. And there are numerous types of statistical tests. You can spend, a whole lifetime learning about these. And I'll explain a little bit about this in a few minutes, but just examples. There are t-tests and ANOVAs, which are fairly simple ones that are often used in language education research. Correlation, regression, factor analysis, logistic regression, which is one that I like, multivariate analysis, A/B testing, which is used in business research, by the way, in case you're interested. Let's say you're working for a company or a researcher, and you have 2 versions of a new product. You give them to 2 different focus groups, and you compare their reactions. You do collect survey data, and you do statistical comparisons of their reactions. Or you have 2 different versions of a new company website, and you give each version to a different focus group, and you collect statistical data and compare the results. That's A/B testing, which is really just a business variation of the classical scientific research design with experimental and control groups. In statistical research, we have what's called a dependent variable and independent variables. And the dependent variable is the main thing that you're measuring, what you're interested in explaining. And then the independent variables are factors that maybe influence the dependent variable. So let's say you're interested in test scores, test results, or improvement in test results over time. That's your dependent variable. It's kind of what you're measuring. So what you're trying to explain. And then the independent variables are other factors that might be influencing that dependent variable, or that result or outcome variable. Other factors that you're interested in exploring, and you want to see if they have an effect on the outcome. And this could be a number of different things. I'll give examples in a few minutes. And when it comes to especially social science research, we sometimes talk about operationalizing our variables. So what does that mean? Let's say I want to study something like language proficiency. It's really hard to measure, and there's no one agreed upon way of measuring it. Depends, kind of depends on the purposes of your study and what kind of resources you have. But a common thing might be to take some kind of standard test score. Maybe the institution has its own standardized test of language ability, or if you really don't have any resources, maybe you just get the subjects, test scores from a standardized test. But let's say you're interested in measuring their improvement in a particular grammar skill. You might come up with your own test and give them a test before and after the teaching experiment. And that's your dependent variable. You're looking at the test results and changes between before and after. So you're going to, for the purposes of your study, you're going to define language improvement or improved proficiency or proficiency on this skill by the test score. It's not necessarily fully accurate or it's a perfect measure, but for your purposes, you're going to define proficiency or proficiency on a particular skill as the number on the test score. In other cases, you might need to operationalize other variables, like just for the purposes of this experiment, we're going to define motivation as, well, their score on a particular psychology survey or psychology inventory of motivation. And that'll be how I define motivation for the purposes of my study. So a lot of research is correlational. And correlation is simply a mathematical relationship between two things, between like an influencing factor and the outcome or dependent variable. So, simple example. Let's take taxi fares as an example. Let's say we're measuring how much people actually spend on taxi fares in, say, Germany. Let's say, okay, the base fare is €8, and then after that, a certain amount of money is added to the meter based on distance. It's incremented based on distance. But then there are other kind of factors that are involved, traffic jams and such. Time, that's another factor, but we'll just keep it simple for now. It's distance. There is a direct relationship between the taxi fare and the distance driven. That's a direct correlation. And let's say the driver charges €0.50 per every kilometer on top of the €8 base fare. So you get a correlation graph that looks kind of like this. The base fare, that's the intercept. Think of your high school algebra. Y equals ax plus b. B is the intercept. That's kind of like your base fare. That's not so much of interest, but what we're interested in is this relationship, this correlation line. So you've got all these data points for the different fares measured on different trips, and then you plot them, and you can draw this line between them that shows the relationship, the mathematical relationship between the two. It's a correlation line. And in certain contexts, people call it regression, and there's a technical difference, but we won't get into that here. But you've got a correlation between two things, the distance driven and the fare that you end up paying. That's a simple example of a correlation. Now, language examples. You can have, say, scores on a language test for your study, and then students' scores on a motivation survey, a psychological inventory that measures their, let's say, their intrinsic or internal motivation. That is how much motivation, desire, interest they have for the subject. And you get a simple correlation. It's a simple numerical correlation between one number and the other. So in the previous example, the taxi fare was a dependent variable. It's the outcome you're interested in measuring. The independent variable was the distance driven. Or if we have scores in motivation, we're interested in the scores as a way of operationalizing maybe how effective this teaching lesson is. Or in this case, we're interested in scores as an outcome measure of motivation. And motivation is the main factor that we're measuring. And we see there's a direct correlation between motivation and test scores of some kind. Both are numerical data, numerical factors. Now, let's change the independent variable to something that actually is a category. Let's say you've got scores on, say, a language test, and instead of a numerical independent variable, we've got category. What's their first language? Chinese or Korean? So that's a categorical variable. And so you've got a category, and it's got two simple levels. It's got Chinese students, maybe you got 30 Chinese students and 30 Korean students, and you compare their outcome scores. And you may have heard of something called a t-test if you've read any applied linguistic studies. Well, a t-test is kind of like a correlation, but it's just you've got, instead of a numerical independent variable, you've got one simple category. It's got two levels. L1, their first language is Korean or Chinese. And you do a t-test for that. It tells you if there's a meaningful difference between these two groups of learners or students. Now let's make it a little more complicated. For more complicated designs, instead of a t-test, they'll use something called an ANOVA. You can take a course and learn more about that. That's for slightly more complicated things where you've got maybe a three-way category like Korean, Chinese, and Thai students. And maybe you've got another categorical variable, another category of students who are introverted or extroverted. And let's make it even more complicated. Let's add in motivation again. Maybe for this we won't use an ANOVA, but maybe something more complicated. Statistical test like some kind of a multivariate analysis, like multi-level analysis or something like that. Not important that you know that. It's just that there are a lot of sophisticated tests, a lot of choices we have in statistics for different kinds of cases. The same principle applies here. You have a kind of a correlation line, and you have either numerical variable, independent variables, or you've got categories like they're L1 or something like that. And you have different types of different data types, especially for independent variables. You can have a numerical or continuous variable. It can be any number in a continuous range. Let's say test scores could be any number between 0 and 100. It's on a continuous scale. Dependent variables are often numerical. Independent variables can easily be numerical. You might have categorical variables where it's like some category like male, female, introvert, extrovert, or their language background. There are a few other kinds that you come across: ordinal or scalar variables, something that's on a scale. It's one extreme to another. So for example, a survey question where you rate something on a scale of like 1 to 5, 1 to 7, that's an ordinal scale. That's a different kind of variable. And binary variables like yes, no, good, bad, passed, failed, or something like that. True, false. Those are binary variables. These are kind of helpful to be aware of when you're reading research like this, and when you are reading papers to use to write for your own college papers, applied linguistics research or sociology studies or whatever, education studies. Maybe if you're just at a college level writing a college paper, it's not important to understand all of the details, but just have a sense of what's going on when you kind of skim through the statistics section, the research methods section, just so you kind of have a feel for what's going on and it's not all overwhelming. But again, if you're using a paper as a source for just a college paper, it's mainly the general discussion section you want to focus on. What were the main findings of their study that are relevant to the paper that you're writing? When you get into graduate school, you might get into more detailed critiquing of their experimental procedures and their statistics. This can also be useful for business. If you are a college student, you're thinking about a job, well, hey, a lot of companies need data analysts or business analysts. And if you learn, some basic statistics and at least are aware of these different types of concepts that I've talked about today, maybe learn a little bit more of them through online courses, you might try to get a company job doing business analysis. There are a lot of jobs out there for business analysis, business intelligence analysis, data analysis. They require basic knowledge of this kind of stuff that I've talked about, and using databases as well as visualization software so you can make presentations to your managers about what's going on at the company. Something to keep in mind, career tip for you. Okay, if you have questions, type your questions in the comment section below. And this is actually, to me, really interesting, fun stuff. I took a lot of stats courses when I was in my PhD program. I didn't like it at first, and frankly, my first two professors were horrible. They just wrote math equations on the board all the time and didn't really explain anything very well. But then I had a stats professor for my third and fourth stats course who explained things really well, and I saw how this stuff was relevant to data that I had, and I thought, this is cool. I can use these methods to analyze my data and do something new that hasn't been done before. And that's when I started to really like statistics, and again, more so the concepts, not so much like the hardcore math and all the equations, but the concepts of how this stuff works. It's very useful, very practical, and I'm glad that I went that way, because statistics is kind of fun. It really is. Okay, in my next video, I will talk a little bit, get a little philosophical. Well, philosophical and scientific. I'm going to talk about theories and models and laws and other stuff. I'll talk about that. And then in my last video in the series, I'm going to get really philosophical, talk about academic worldviews. Well, I hope you enjoyed this, or at least learned something from this. A lot of people don't find this terribly exciting, but I think it is. So have a good day, enjoy, and I'll see you back in the next video. Goodbye.